So we have a question here. What's up, everybody? How you doing, man? Yeah, so we got a question here, brother, sister. So peace, family. So find the Maclaurin series expansion of a sine of x to 3 times. So let's start with 3 times, face the face part, and then we're gonna go for the second party and the last part. So for the face on solution, let me do here solution. So first of all, you need to know you have to know Maclaurin series formula. So formula say f of x equal to f of 0 plus f of 0, but this is face prime, and then x power 1, and then over 1 factorial, and then plus, now we go f of 0. You see, this is no prime, face prime, this must be second prime. You take x square over 2 factorial, then you continue, see f of 3 prime, and then you go 0, and then x power 3 over 3 factorial, and then you add to the last one. So the last one is gonna be f. So the last one is gonna be f of 0, but this is gonna be n prime, and x power n over n factorial. So the term before it must be f of n minus 1, and then you got 0, and this must be x n minus 1 over n minus 1 factorial. So now we go. So then after that, now we go. What we have to do now, we have to find what is f of face prime, f of 0, f of face prime, f of second prime 0, etc, etc. So what we're gonna do, we start f of 0, but before you get f of 0, you have to know what is f of x. Our f of x equals sine of x. We say f of x equal to sine of x. So we want to get f of 0. So it means plugging in here 0. So it's going to be sine of 0 equal to 0. Now we go for the next one. So we go for what for? F of 0. We know now we go f of face derivative, f of face derivative, f of face derivative of x. When you derivate sine of x, you get cos of x. Okay, now we go. So now quickly, so these, they say 3 times. So this f of 0 is not going to give us any term because everything is going to be 0. So long we haven't got any terms. So now let's go for f face prime. F face prime equals cos of x. We say f of face prime, this is going to be cos of 0. Cos of 0 equal to 1. Oh, so this is going to give us 10 because f of 0 prime 0 means it's going to be 1 times x power 1 over 1 factorial. So here we're going to have a 10. Now we go for the second one. So long we have got 1 term. Now let's go and try to get the second term. So this is going to be f of the second prime. When you derivate cos of x, you get negative sine of x. Now plugging in 0 because we want f of the second prime of 0. Second prime of 0. So this is going to be negative sine of 0 equal to 0. So long no term, because if you take 0 times anything, everything is going to be 0. So no term over there. Now we go for the next one. So for the next one, f of third prime. F of the third prime of x equal to, we got negative. When you differentiate sine, you get cos of x. So let's do the same thing. Plugging in here. So f of the third prime of 0 equal to negative cos of 0. Means negative cos of 0 equal to 1. So negative 1. So this is going to give us 10. For third prime is going to give us 10. So we still need one more term. Now let's go. So we go f of fourth prime. F of fourth prime of x. Excuse me. F prime of x equal to negative. When you differentiate cos, you get negative sign. So it's going to be negative sine of x. Negative and negative is going to give us positive. So negative and negative is going to give us positive. So just like sine of x. So this is going to give us sine of x. So f of the fourth prime of 0, if you plug in 0 here, is going to give you 0. So sine of 0 equal to 0. Now we want to go, so that's not going to give us 10 f power 4, even though we don't have a 10, but we know for power 4 it must be f power 4 prime of 0, and then x power 4 over the same thing 4 factorial. So that didn't give us any 10. Now let's try f power 5. Well, I think f power 5 should give us a 10. So we say f of power 6, excuse me. f power, which one was this? This is f power 4, my apology. So f power 5 of x equal to, when you derivate sine of x, you get cos of x. Okay, f of fifth prime of 0. 0, what we're going to get? Cos of 0. 1. So, okay, so this is going to give us what? 10. So, power 5 is going to give us 10. So, we say, okay, so let's write a power 5 here, even if it's not there. but we know it must be f power 5, and then we're going to say this is going to be 0, and then x power 5 over 5 factorial. So the terms, we have already got the Maclaurin series, all the terms. Now let's get to the Maclaurin series in the right form. So we say right. So now our f of x means this f of x equal, so the first one, f power 0, is going to give us nothing, so that's not 10. Now f power 1 means f prime 1 is going to give us 1. So this is going to give us 1 times x power 1 over 1 factorial. Now we go for the next one, plus. Now f power 2 prime equal to 0. So this is going to be 0, no 10. F of third prime equal to negative 1. So this is going to give us negative 1. Positive 1 times negative 1 equal to negative. Excuse me, positive and negative is going to give us negative. Oh, it's fine, just a negative. And then negative 1 times x power 3 over 3 factorial. Now we go for the other term. So another term we got is f power 5. So I'm going to say which is going to give us 1, and then it must be x power 5 over 5 factorial. So we already have it 3 terms, no? So I can just simplify, say plus and minus is going to give me minus right there. So these 2 terms here is going to give me minus. I don't have to say plus anymore. You just what? Minus, and then this is same as say our f of x equal to 1 over 1 factorial equal to 1. So it's like say x minus x3 over 3 factorial plus x power 5 over factorial, because 1 times anything, just something. Now we go. So now the next step here, somebody could have simplified further if you want. You could say this equal to just say x minus negative 1 over 3 factorial. 3 factorial is like 3. 3 factorial is 3 times 2, but you can plug in the calculator equal to 6. So x cubed over 6 plus x power 5. 5 factorial is 5 times 4 times 3 times 2 times 1. And then you're going to write your answer here. But you can leave the way how it is like this and you get your mark. Now we go for the next one. So for the second part here, they say find sin x over x, but you have to use Maclaurin series. Write down Maclaurin series and find sin x over x. So sin of x we got, which we have expanded by using Maclaurin series. So if you want to get here, this is number 2, right? Number 2, yeah. So let's do here number 2, right? So if you want to get number 2, this is number 1, solution number 1. So if you want to get sin of x over x, it's like say 1 over x times sin of x. What is sin of x? Is x, which we have here, x minus x3 over 3 factorial, and then we have plus x power 5 over 5 factorial. Now we say if I take this and this cancel, I'm going to have only 1, and if I take this with a 1x in the second one, it's going to be x squared here, so minus x squared over 3 factorial, and then now we go plus. Now this x multiplied by this, because 1 over x, 1x, and 1x cancel, so it's going to be x power 4 over 4 factorial, over 5 factorial, my apologies. So now it's finished, man. So now we say the last part they say determine. You gotta determine sin of x, but you have to limit, right? So now we say let's limit our term now. So say right. So either there's 2 ways I can do this. I could have taken A is number 3, right? Look, there's 2 ways I can solve this question. I could have said limit. Either I can take this and say limit, instead of writing sin of this, or let me write that one and then I'll show you also. I will solve this. X approach equal to 0 equal to sin of x over x. Or if I don't want to write like this, so for this one, let me show you this. So this is same as say limit x approach to 0, and then I have my 1 minus x square 3 factorial, and then plus x power 4 over 5 factorial. So remember, if this x, if I could have used this, I can solve this or that one. Let me start solving this using El Hospital rule. So there's something called El Hospital rule, right? El Hospital rule meaning, before you do El Hospital rule, let's try to plug in here. When x equal to 0, this is going to be 0. excuse me. So it's going to be sine of 0, because if you plug 0 here, it's going to be sine of 0 equal to 0, and this 0 is going to be 0. So this is called undeterminant, because 0 over 0 is undeterminant, or if you get a infinity over infinity, also how we call it, undeterminant. And when it's undeterminant, what you have to do, you have to differentiate numerator and denominator separately. Do not do quotient rule, even though it looked like a quotient rule, but don't do that, please. So this is undeterminant, right? So now let's differentiate numerator and denominator separately. So when you differentiate sine x, you get cos of x. So this is going to give us cos of x over, when you differentiate x, you get 1, but we still have our limit x equal to 0, and this we call it El Hábito. Let me write here, it's like hospital, but it's not hospital, it's just El Hábito rule. So what I'm going to do here, if I substitute, let's substitute again, because every time I'm going to have to substitute and see what happened. X equal to 0 means it's going to be cos of 0. Cos of 0 equal to 1, because it's going to be 0 here. Cos of 0 equal to 1 over 1, because this x equal to is not going to have any effect here. There is no x, so you're only going to substitute on the numerator. Cos of 0 equal to 1, 1 over 1 equal to 1. So if I had to take this left part and solve using El Hábito, I could have got what equal to 1. If I don't want to do that, I could have take this side here, because the same thing also, just like I say, if I take this and I substitute straight, look, x equal to 0 means this x equal to 0 is going to be 0 square equal to 0 over 3 factorial. Everything here is going to be equal to 0. Here we're not going to substitute x equal to 0 because there's no x, so this 1 is not going to have any effect. It's just a constant number. X equal to 0 here is going to be 0 power 4, 0, 0, 5 factorial equal to 0. So I'll be left only with 1. So my answer equal to 1. So I could have done either way. And that's the final answer. Thanks a lot. Peace.
More ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne.
So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and excuse me, and things gonna improve slowly, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom.